So I just wanted to make this video real quick to go over what I've been working on over the past couple weeks, and just to give like a brief intro to the progress that I've seen from these models from the big labs like Anthropic and OpenAI over the past couple months, right? So when Fable 5 first hit the market, what I did was I had actually cloned a section of my repo that I was working on, and I essentially had Fable go through it. And basically, when it was first released, they were saying that if you're doing work that is considered like frontier level, or it could be construed as a competitor to Anthropic's models, that they would basically silently degrade the performance of what you're working on, right? And so I tested that out, and it actually was true, and it did that for my specific project, even though, again, I specifically put in the disclaimer saying that, hey, this is not supposed to be a competitor or anything like that, or an alternative. Still did it anyway. So I didn't really use it after that. I just went with ChatGPT and a little bit of Gemini. Unfortunately, from my experience with Gemini, even though I want it to be my main driver, my daily driver, is just really not there, because the coding ability compared to even ChatGPT, and it's just not as good, right? And then on top of that, basically what happened was it's almost like the personalities of Gemini and ChatGPT kind of like swapped, to where you have the situation with Gemini, like every single idea that you have is like the most amazing idea ever, right? And when it comes to like coding, maybe on like a conceptual level, Gemini can handle certain things, not even just anti-gravity. I'm just talking about the actual chat experience. But overall, I've just had a lot of issues with Gemini giving out bad information or incomplete, or it's been misinterpreted, that kind of thing. And Claude just overall has been the clearest out of pretty much all the models when it comes to not just coding, but just handling like physics related stuff, you know, other aspects like mathematics. It's just overall the clearest out of pretty much all the models. So why am I saying all this, right? So basically, what I was able to do with Fable, right, once they actually brought it back and they kind of lifted some of their restrictions, is that I built a streaming sort of adapter to a world model, right? So what does that what does all that mean? So essentially, there's a line of world models, right? So a world model is essentially how either an agent or an embodied system like a humanoid robot, how do they effectively make decisions and act within a world, whether that's a simulated environment or the actual real world, right? That's what these world models are being basically designed for, trying to figure out how can we get these robots or these agents within digital environments to actually not only have a robust enough sort of system to where it can actually have these complex behaviors, but to see how these systems can actually evolve once those systems are actually in place. And so I started working with Dreamer v3, right? So this is the previous generation. We're on Dreamer v4, or excuse me, Dreamer 4 right now. And basically, the difference between the two is that Dreamer v3 uses a SSM backbone. So that's a state space model. And then Dreamer 4 uses a transformer model as its backbone, right? And basically, the main differences between those two is transformer is basically the industry standard algorithm that's being used for the most part when it comes to world models, right? Pretty much every single lab out here, except for about maybe a handful, they use transformers as like a heavy driver of the computation of the world model. Where again, the previous generation, Dreamer v3, uses the state space model, and for a while that was sort of marketed as an alternative to LLMs or an alternative to transformers. But on the third iteration of these state space models, the mainline model is called Mamba 3. It's a hybrid system, and they had a interwoven blocks. So state space model blocks and transformer blocks basically throughout the entire architecture, which basically said that over the years, they were trying to, again, position the state space model as a stronger alternative to transformers, but they weren't able to do that, so they had to settle and they had to interleave both of these or certain aspects of both of these systems, right? So basically what I was able to do with Fable 3 was I was able to actually put together a streaming adapter for the world model, right? So essentially, the way that it works is with most world models, you have a pre-trained backbone. So this basically sets up, like during the training of that backbone, it sets up all the rules that the agent will actually abide by, like the laws of physics, taking in visual information, taking in all these different kinds of data types, and basically compressing it down into the weights of the model to where it has a certain level of understanding of what's going on in the world. Now, the downside of this is that models that are trained in this manner are not necessarily the best when it comes to continual learning, right? So the ability for the agent or for the robotic of the humanoid to basically walk around and learn in real time. Now, when it comes to like agents, when it comes to like, agents behind the screen, it's not really a big deal because especially when it comes to these foundation models, you have a new model coming out pretty much every couple of months. So whatever is missing from the model, they'll just basically roll over until the next version, and they'll just keep on doing that over and over and over again. However, when we're talking about humanoids, right, especially if you want like humanoids in the house to like clean up the house, do your dishes, cut the lawn, do stuff like that, you can't really have a situation where the model, or excuse me, where the robot is constantly having to be shut down and basically retrained in order to learn how to use a microwave or learn how to, operate the dishwasher, right? You need a system, you need a series of algorithms that is robust enough to basically be able to be trained and learn in real time. So it's constantly moving, it's constantly walking around, interacting with things, and it's able to essentially learn from experience and not have to be shut down. And so basically that's what I'm trying to figure out how to do, or at least some of the aspects of that, right? And I'm not going to go over the code in this video right now, that's going to be in the future, but essentially I've been running experiments on a 4070, so this is actually previous generation of GPU, and it's about a mid-tier GPU, so it's not too powerful, not underpowered, it's just sort of in the middle. And I've been making a lot of progress just on this 4070, right? Now I have access to more powerful hardware via SageMaker. I actually went through the startup program. The only thing with that is, of course, it takes a lot of money. I believe SageMaker is either it is the most expensive or it's one of the most expensive platforms that you can just train models on and that kind of thing. So before spending, $30 an hour, $60 an hour, running on their GPU clusters, these algorithms, I really want to make sure that I have everything in place and I'm doing as much as I can at a smaller scale before just burning money on these clusters, right? And so again, in the next video, I am going to go over some of the actual experimental data that I generated. It is quite a lot, even though it was only about a week and a half of me actually going through and building out this system. I ended up doing like multiple 6.5 hour to like 8+ hour runs. I believe my longest run was 13 hours, just a little bit over 13 hours. And I've just been putting my laptop through its paces and just training the model and basically getting everything dialed in from the system.